Welcome to this developer skill sprint, create and consume a custom REST API using DataSnap. These skill sprints are short tips, tricks, and techniques to show you a capability in RAD Studio XZ6. 20 minutes, one topic, demo, discussion, and live Q&A at the end. To build multi-tier and multi-device applications that can connect to cloud storage, connect to SQL database backends, and can work with mobile and desktop clients, you need to use our REST DataSnap technology. DataSnap Server allows you to create a server-side application that can access the SQL databases wherever they are on your network. The DataSnap Server consists of a DSS server component, a server class, and a transport class. The DS server manages the creation and lifetime of transports and server method classes. The server method class or classes contains published methods and database access that you can use in your application. DataSnap supports TCP, HTTP, and HTTPS. We have a DataSnap wizard that helps you get started quickly. For the demonstration, we're going to use a demo that Pavel Glowatsky did. We'll show you how to create a DataSnap REST server and a client that runs on mobile devices.
I'm going to demonstrate the new technology in the DataSnap framework for working with FireDuck and converting results from database queries into JSON using reflection. My demo contains is a project group that contains a server application and a mobile client application that can be compiled to either Android or iOS from the same code. So server has been generated using the DataSnap web broker application wizard. I have selected for standalone application, so this created for me an executable that is both a web server and a DataSnap web application. I could have also compiled as a DLL to deploy to IIS web server or Apache web server. And in the next tab went for the FireMonkey application for my forms and selected also 8081 and HTTPS protocol, so I could have security through using the HTTPS communication. In the next step, you need to specify the certificate file name and key file name. So these two files for testing purposes I have generating using OpenSSL, so you can also do it for yourself. It's just for testing in a production environment. You would probably obtain those certificates from a certificate authority organization. In the next tab, you specify the functionality of the server. So I have selected for just authentication. I have generated server methods class and sample methods, and also specified encryption and compression, so my communication between the server and clients will be encrypted and compressed. On the last tab, you can specify the base class for server methods instance. So this is the functionality that will be exposed to clients. I want to use a data access component, so I need to have a data module as my base class. So in a server container unit, we have a DS authentication manager. So this component is responsible for performing authentication and authorization. It has events on user authenticate and on user authorize. On user authenticate, we provide some custom code to do authentication. So if the user is not username is not empty, then we set the parameter valid to true. Otherwise, it's false, and the user will not be able to access the functionality of the server. And additionally, if the username is admin, then we are going to add it to the user roles admins. Another property here is roles. So here we have a special definition that if the user is in the admin's role, then it is allowed to call our apply changes department employees JSON. So there is also another web module unit that was generated by the wizard. It contains DS HTTP web dispatcher component, and it contains the filters collection. So this is where different filters has been added by the wizard. The first two are responsible for encryption, and the third one is responsible for compression. The functionality of the server is defined in the server methods unit. So these first two methods has been generated by the wizard, the echo string and the reverse string, but the following methods has been added. We have three methods: get department names. So this method will return to the clients information about the names and numbers of departments encoded as a JSON object. We have also functionality to get specific and more detailed information for the given department. So the idea here is that from this first method we get the IDs of and names of all departments, and if we select one of the IDs, we can then request from the server some more specific information about the all employees and all departments from the server. And the last method is used to apply changes back to the underlying database. So let's have a look into the visual components of this form. So we have a connection to the database. So this is our interbase test employee database. We can check if we can connect to this database. Okay, this database contains many tables, but we are specifically interested in the departments table and also the employee table. Our server methods class contains these three queries. So in the first query we specify department number and department, and two other queries are parameterized. So we specify a department number to get all information for selected department from the department table, and the third query returns all information about the employees that are working for a given department. What is the functionality of our server? First of all, we have the get department names JSON. In this method we are using an FD query department names. First we're making sure that it is closed before we proceed, and then inside of the data fireduck JSON reflect namespace there is a special class called FD JSON datasets that we can use to return datasets from the server. So that's very interesting because we can return in one operation more than one dataset. We use this special class FD JSON datasets writer with its static method list add that takes the result of the query, add them to the FD JSON datasets. What we return from this method is FD JSON object. So we use a special class TFD JSON interceptor that converts those datasets into a plain JSON. In the next method, get department employee names, that takes a department ID, we demonstrate that we can in one operation return more than one dataset. So basically similar start, we make sure that both queries are closed. We specify a parameter because these two queries are parameterized. We generate a JSON dataset and add both datasets to the list. They are identified by these two strings. So these two strings basically identifies those datasets within the datasets collection, and in the same way we return data back to the client. The last method, the one that is protected by our authorization manager, is to be able to apply changes to the underlying dataset. So this is a method that does not return any value, but it accepts the JSON object with all the delta information. So what we do is we construct new FD JSON deltas class, and we create a deltas class using the values that were actually sent by the client and encoded as a plain JSON. We need to also have this FD JSON errors in case there are some errors, and we can apply updates to the underlying query. So both query department and query department employees. There is a command property that needs to be passed here, and also possible errors. So I need to make sure that the server is running before I can create a client application. Server is running, I can actually start it. So my client application is just a FireMonkey mobile application C++ builder, and I have added to this application some code using the wizard. So we have a DataSnap REST client module wizard that you can use to actually generate client code. Using this wizard, I have generated client classes unit that was generated by the DataSnap proxy generator, and it contains all the values, and specifically it contains the class called tServerMethods client that has methods that corresponds to the methods of the server methods class. The second unit that was generated is this client module unit. So that's just a data module that contains DS REST connection component with all the information about the port number, about which protocol is used, and possible username, host, and so on. This class also has this get server methods one client property, so I don't have to instantiate my tserver methods one client. It is instantiated on the first access to this property. Okay, so inside of my client form, I have 3 tabs. So these are the tabs with the list of all the departments. It contains a list view. The second tab specifies information about the department and all the employees. So in the employees part contains 2 tabs with the list of employees and individual employee information. There is also another tab in this application to specify the connection information. So if I go to my settings, I can specify the host name, the port number, protocol to be used, and also username and password. I'm using visual live bindings very extensively here. Before I can proceed, I have added to my project to have a better organization of my code. I have added a data module with 3 memory tables for storing data coming from these 3 different queries. Important step here is that in order to use visual live bindings, I need to define at design time field definitions. So for example, department names will have this department number, department, head department. For different tables here, I have a structure defined as a field definition, so I can then use them for visual live bindings. Another thing that I need to make sure this data module is used by your form. In the visual live bindings designer, I see the definitions to my different elements on the form. On the first tab there is a list view, and I can connect its text property, so the individual list items will be connected to individual records and the department will be displayed. And for displaying the department number, I'm using item detail. So in order to see this item detail here, I needed to actually go into the list view, and in the list view I have selected item appearance to be list item right detail. By default you just got a list item, then you don't get this item.detail. So if you have list item right detail, you can bind data. I have also bound these other values of a department to different edits on the next tab, and data from the employee table I have a one list view with the just employee information. And I can actually go ahead and try to run it. I have selected 32-bit Windows as my target platform, primarily for testing, so I can quickly see what my application is doing. And now I should see the list of all the departments. If I select one of the items, I can get an information for a given department. I can preview information for a given employee. So that's for different departments. I can do different things. So also I can change things. So in engineering, maybe I will change the budget to be something different. And here we have apply updates. If I stop this application, run again, and we go to the engineering, we should see the change that the budget has been updated in the underlying database. And I can also go ahead and compile my application for Android. Okay, now we see the list of the departments from our remote server shown in the list view. So in this way we have seen how you can easily create DataSnap servers using Interbase, using FireDuck database access technology and the new JSON reflection to quickly create REST servers with HTTPS security and also clients using wizards that can be compiled to both Android and iOS.
This is the Object Pascal Delphi version of the same basic application. It's in the samples for Object Pascal DataSnap FireDuck JSON Reflect. So here's the main application for the DataSnap server that was built with the wizard. Here's the server methods unit with the database connection, the department query, the department names, department employees query. Here's the web module unit, which has the DSS server, server class, and web dispatcher. And here, in this case, is a FireMonkey desktop application that is connecting through REST and JSON. The server methods, same as you saw in C++, this is the Object Pascal version. Get department employees is going to be a JSON data set. Turn off the queries and then get the query for department and department employees as JSON and then send it. Here's the JSON datasets to JSON object. The apply changes for department employees. It gets the deltas from the delta list and passes those changes back. Here's the get department name, which activates the department name query, creates a JSON dataset object, and then sets the writer to get the data from the query and add it to a JSON list. And same thing over here, get department name JSON. The result is a JSON data set. So we get the query and get the data set. And then here's those two methods that were created by the wizard itself. All the functions and procedures that are in the public area of your server methods class, tserver methods 1, those are all exposed through DataSnap so they can be called from your client. Over here on the client, calling apply updates. Down here says, okay, we're going to get the deltas, and then we're going to call the server method client, apply changes, passing the delta list. So that's the interface back. If we scroll down, here's the update department employees. So again, getting the data set and appending any data that was changed in the deltas. Getting department employees, we're going to call get department employee from the server method class. Same code in both Object Pascal and C++ using JSON and the REST interface from a client, either a desktop or mobile client, calling into the DataSnap server. The nice thing about using REST and using FireDuck for the future is that we can move this DataSnap technology off of Windows to other platforms in the future. And on our roadmap, we mentioned work going on for Linux server. The previous technologies for DataSnap used a Windows-based interface. Using FireDuck, we can start looking toward putting DataSnap's REST servers on other platforms. And having the Apache support gets us moving along the way as well. Here are a few DataSnap resources that you can use. We have a lot of documentation in the online doc wiki. And here are some of the URLs that get you to the top levels of developing DataSnap applications. We also have videos using DataSnap and mobile at our recent Code Rage and C++ Mobile Day events. There's a sample for Object Pascal to use DataSnap and the FD-JSON Reflect technology, and Pavel Glowatsky has also made his C++ DataSnap sample code available at a recent blog post on June 4th. This Thursday, I'll be back to show you how to push a notification from a Windows desktop application to a mobile app with the Convey backend as a service. You can also apply all of the skill sprint tips, techniques, and tricks by downloading a 30-day free trial of RAD Studio XE6. And now it's time for Q&A.
Can JSON be used without DataSnap?
Yes, you can use JSON objects directly yourself. We also use the JSON runtime library for just calling and dealing with REST libraries or REST servers that have nothing to do with DataSnap. So if you look at the REST client library, it also takes advantage of the JSON support. So those JSON objects you can use in whichever way you want to.
If you have lots of queries to be made from your client, what's the best way to do so with using the least amount of time? So is there a way to bundle batch queries maybe or something like that?
There are options to decide how much data you send over, and those are parameters on on FireDAC if you want to send a whole table, for example, or you want to send X number of rows.
How can we store JSON in a cache manager for later use?
Well, you have access. You saw the code where there's JSON objects that are created. So you could stream the JSON instance, whatever it is, if it's the deltas, if it's the data that came from a DataSnap server, you can stream those objects out to local storage. Pavel had this example. He brought the JSON into FDMem tables, FireDAC in-memory dataset, and from there you can save them either as XML or FDMem table has its own binary format for local storage. But yeah, if you just want to do your own thing, I would stream the JSON objects out to a local file and then stream them back in.
Can you use DataSnap on OS X through FireMonkey?
So I haven't tried, but it should be possible. That'll be a good blog test. In the previous DataSnap that was based on the DBX framework, that was totally tied to Windows. But now using the REST technology with DataSnap and FireDAC, it should be possible. We haven't certified it and I haven't tried it, but that'll be a good thing to try. So, and Stephen mentioned if you use FDMem table, you can save not only the data but the deltas to disk and load them back again in the briefcase model of connected, disconnected, mobile app or desktop app.
So this says, in this example, your FD connection was in the server method. Is that the recommended design? Just wondering if it's okay to create a data module and put the FD connection there for all server methods units to share.
You can create a data module if you want. It's better to create server modules because then you can control the lifetime of those server classes and server modules. You can do connection pooling and other things for DataSnap clients that are coming to DataSnap server. But you can have a server class with server methods, but then you'd have to think about how you might control all the data modules and data access yourself. The nice thing about having multiple server modules is that you could have different server modules with different database access, and then you can control the lifetime and pooling and access of them. But it's possible.
So should the FD connection be at each server method unit that needs access to the database, or can you share one between multiples?
Do you want to share the data with multiple connections? That's fine, because each connection will have its own deltas. Each connected client will have its own deltas, and it'll play back through through JSON and through DataSnap, whatever protocol, TCP, HTTP, HTTPS. When you say apply updates, each of those can call their apply updates. So if that's what the question was about, multiple clients can connect and make changes to data just as they would need to. And if there's a collision, the deltas include the original value and the changed value. So if there's some problem where multiple clients are changing some data, then you'll get an apply updates error, and you can handle that error by ignoring it, trying again, figure out how to go fix the problem. And that's where the apply updates error handling can help you on the server side and the client side. There was one there about where can you deploy DataSnap server apps, and right now it's
yes,
it's Apache 2, 2.2, 2.4, or IIS if you create the Apache module or an IIS DLL. So Apache 2, 2.2, 2.4, or IIS currently.
Or as a standalone executable.
Or as a standalone executable and use CGI.
But the IIS or Apache is recommended for performance reasons. What is the best way of transferring a large number of records from a web server into a client, like more than 5 million records?
Bring them in as you need them. So
Yeah.
there's, again, a FireDAC setting for how many rows get sent over at a time. And as you request more, bring more at a time.
Is Microsoft SQL Server access supported by FireDAC without using ODBC?
Yes, there's a FireDAC can go through the native Microsoft SQL Server client library for direct connection to Microsoft SQL Server database. Oracle, Informix, DB2, There's a whole list of them. If you go to the doc wiki for FireDAC, you'll see the whole list of databases and their versions that are supported.
Is it possible to use DataSnap in hybrid mode, FireDAC on the app server and Midas on the client? Of course, Windows-only client and updatable data sets.
Well, you can always use client dataset instead of FDMEM table. That's your choice. You need to carry along, link in the Midas static library or carry along the DLL. In order to get all of the magical stuff of dataset provider and resolver, there you'll have to use the DBX connection framework, because all that's tied together, T-SQL connection and so on. It's that question of, do you want to be tied to Windows? You can still use the existing DB Express DataSnap. It's still there, and you can use client dataset if you want to use that. You can use, on the server side, you can use FireDAC for your data access. That's fine as well, because it's just a data set at that point. It's your choice. We've moved to this next generation technology so that, again, as I mentioned, that we can decouple any Windows specifics from the DataSnap server side, and if we've already done that, of course, from the client side, so that you can go elsewhere now and in the future.
So what is the difference between DataSnap and DataSnap REST?
Well, DataSnap is the umbrella technology, and DataSnap supports TCP, HTTP, and HTTPS, and the wizard gives you several options. You could choose to use REST. REST means use HTTP or HTTPS and use the REST protocol, which are the slash, URIs that are added versus just using a port address and using TCP or HTTP under the covers. So again, DataSnap is a whole set of components and technologies, DSS server and so on. But REST is just one form of architecture versus using a different architecture. You could even create a DataSnap server or a REST server with HTTP component, Project Indy, and somebody was asking, what about using other distributed computing components? And again, you can use the JSON packets, the JSON classes, all of that stuff. But it's the combination of FireDAC and the DataSnap components for lifetime control, session control, client control, all of that is the sum total of everything in DataSnap. And then you can decide which parts of DataSnap to use. You might have a DataSnap server that has no database access. It might just serve up some interface methods that pass data, XML, JSON, whatever it might be. It's just if you choose to build a DataSnap server with REST, that implies HTTP and JSON, usually, although I've seen REST servers that also send XML.
If you just use the TCP, can you secure that as well?
You'd have to do all that yourself. TCP and HTTP, it's just the raw lower protocol. If you want the built-in security support on the link, then you can use HTTPS as Pavel showed, and that works in Delphi and C++. If you do TCP, then you're going to have to use an encryption library of some kind. There are many out there to encrypt stuff that you're sending back and forth through TCP or HTTP.
Is there a method on the TCP DataSnap that would make it easy for you to just hook in there and encrypt everything as it goes back and forth?
No, there isn't. Let's see. If you're using DataSnap, you could use still an encryption filter. So a filter can be used in TCP, HTTP, and HTTPS. Encryption filter, and if you look at the lower level filter class of which we give you the examples, compression, RSA, and PC1. It's just bytes in and bytes out.
If you use HTTPS, do you have to use JSON and REST, or can you use the other data format?
If you can send whatever you want back and forth. If you're using REST and JSON as it's related to what we're doing, then things come over as JSON. But again, your server methods can pass any types they want, including plain old objects. And you don't have to build a REST server. You could build a web server. You could build a console application and do whatever you want in your server methods. The server method parameters can be, again, those are all the methods you put in one or more server classes, and they can have any kind of parameter types that you want to send, floating point or whatever, and then they'll get marshaled appropriately. If it's a REST server, then JSON will be involved.
Is DataSnap just a layer to interface with all different types of SQL servers?
Well, no, DataSnap is that conveyance part. In the mobile world or in the thin client world, of course, you might have in your DataSnap server one or more server modules that might talk to one or more remote databases to create a multi-tier architecture. And then the passage of dataset data through queries from the server, DataSnap server, to the client is what you saw in the demonstrations today. But again, you can have methods that would pass a simple type, pass an integer, and return back a Boolean or whatever you define for those server class interfaces. For mobile, the challenge with mobile is if you got a mobile app and you need to talk to it, let's say a Microsoft SQL server, well, the Microsoft SQL server doesn't give you a client library for iOS. So if you're building an iOS app or an Android app, they don't deliver a Microsoft SQL Server client library that you could link in for Android. They do have a client library for Windows.
Don't use it.
Right? So how would you get to a SQL database? You could either create your own interfaces and do TCP HTTP calls to a server, and inside of there, talk to the Microsoft SQL Server client to do queries and open tables and update tables and delete rows and whatever. But you're not going to be able to do that on mobile. Oracle has a Java middleware where you kind of instantiate a Java object and you can communicate through their Fusion middleware. The only databases I know of are Interbase and SQLite. Somebody mentioned to me there's a project maybe in some other areas like MySQL where there might be a client library being worked on mobiles. But for mobile, if you want access to remote SQL databases, you got to do something. And DataSnap server is an easy way to drop database access components in and pass data sets based on queries and functionality and pass the changes back and apply those changes back to the underlying database in a mobile/multi-tier architecture.
I liked how you described it earlier that DataSnap's a suite of components and technologies. So it includes the ability to send data back and forth and also the ability to send data sets and resolve conflicts and stuff like that. So
bitmaps, video, I mean, anything that you can put into a parameter that you would send. Again, there's examples in the doc wiki for passing an object, a plain old object, and having it converted into JSON on the covers if it's a REST server or not, and then reconstruct that object on the other side, on the client side. So Pavel Glavatsky has a whole set of Delphi labs for DataSnap. If you want to check those out, search for that as well.
Which is faster, TCP or REST?
TCP might have a little less overhead, but again, it depends on what you're sending. I think I wouldn't see a transport difference that much. It's probably more the amount of data you're sending.
So Robert says that the Object Pascal version has been updated in XE6 using FireDAC, FD JSON Reflect technology, and FD Connect, which is different from past SQL or DataSnap examples. Says this is great news because he's embarking on a new project, wants to use that. But where exactly can he find this?
It's in the samples. So public user, public user documents. Embarcadero Studio 14.0 /sample/Object Pascal /DataSnap /FD JSON Reflect is the name of the folder.
Okay, great.
Sorry for that long one. I had it in the slide. I'll post it somewhere here. Also, all the examples are on SourceForge. Let me go back to the browser. Let's see, Rad Studio SourceForge.
Your screen's still paused, I believe.
Okay, sorry, I'll turn that on. Yeah, I did that. Okay, so here's the demo code. Let's see, let's browse the code. And if you have XE6 or the trial, you can right mouse click and you can update. So it's XE6 and then Object Pascal. Okay, then DataSnap, and there it is. FireDAC JSON Reflect. Sorry, not FD JSON Reflect.
So, question about DataSnap for Linux. When is that going to come?
When Linux is ready. It's on the roadmap Linux server. So, when it is ready, No date yet.
FireDAC is the technology that we use to connect to the database and pull data out of the database. DataSnap is the technology that moves that data from the middle tier to your client application. And then we use the FireDAC FD table to then reconstitute that back as a data set on the client application. So DataSnap is the middleware. It's the middle tier. It's what moves the data from the client to the server. FireDAC is what you use for dealing with it as a data set, connecting to a database server, etc.
Marco was just asking, does he need FireDAC add-on if he only has Pro? So FireDAC for accessing local SQL databases and local databases like via ODBC is included in Pro. But if you want to be able to do multi-tier, if you want to be able to connect to SQL databases like here in your backend and then build clients that go into the multi-tier system, you need to upgrade to Enterprise. We do have a FireDAC client server pack which lets you connect to remote databases, but not do multi-tier. So Enterprise upgrade is the best way to go if you want to build multi-tier DataSnap servers and all of those capabilities. And Alvin S, is FireDAC the new DB Express? Yes, FireDAC is the future. It has higher performance and supports more SQL databases, versions, and extensions. So it also has FD table, which you saw Pavel use for a local data set. Instead of using the client data set, it can save, XML can save to its own format, has a briefcase model. FireDAC and DataSnap are available, Ed, in the Architect Edition. So it's Enterprise and above, Enterprise, Ultimate, and Architect to do FireDAC and DataSnap. Okay, everyone, we're past the half hour, so that's our sort of limit to, up to 20-minute presentation, some Q&A. Thanks, JT, for chiming in and helping with the Q&A. Everyone, we'll see you again Thursday. It's push a notification from your Windows app, VCL or FireMonkey, to your mobile apps written in Delphi or C++ with the Convey backend as a service. All right, see you Thursday. Bye.